Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 12 video on the chapter of mensuration where I will solve the problems of concept practice problems set number 2 where the problems are based on area, perimeter, diagonal of a square and rectangle and area of path along a rectangular plot. If you have not watched the previous 11 parts on this chapter of mensuration, then I strongly suggest and request that you please watch them also to maintain the continuity of your study on the chapter of mensuration. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the concept practice problems of set number 2 on the chapter of mensuration. Okay, so I have the set of problems on the left hand side. I hope the fonts are big enough so that you can read them. I will also provide a link of the PDF to these practice problems in the description below. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Please note that in mathematics there could be multiple ways of solving a problem. So based on my knowledge and experience, I will solve the problems in my way, which may not match with your way of solving, but I hope you will get an idea of how to apply the concepts. So whatever your method, whatever way you are solving these problems, please follow the way which is most comfortable and understandable to you. Okay, so let's start solving the problem. Question number 1. Question number 1 says that a room is 12 by 12 and 1/4 meter long and 7 meter wide. The maximum length of a square tile, to fill the floor of the room with a whole number of tiles is. Okay, so we have to cover the floor of the room with a whole number of tiles. That is, whole number means definitely whole number means all the numbers, all the natural numbers, and including the number 0. So definitely 0 will not be the number of tiles. So the number of tiles must be greater than equals to 1, and it will be a natural number. Okay, so let's quickly find the area of the room. So the floor of the area of the floor of the room. So area of the floor will be 12 and 1/4 multiplied by 7, this much meter square. Okay, this is equal to 12 and 1/4 is 49, is 49 by 4 multiplied by 7. Okay, okay, so this much meter square. Okay, so this is the area of the floor. This area has to be covered with some whole number of tiles, and it is asked what will be the maximum length of the square tile. Okay, so let's say let the length of the square tiles be x meter. Let the length of the square tiles be x meter. Okay, the maximum length of a square tile to fill the floor of the room with a whole number of tiles. Okay, Mm, Now, if the area, the maximum length, okay. So we have to. So the idea, the problem is asking what will be the maximum, what will be the maximum size of the square tile, so that it can cover, so that um, to fill the floor of the room with the whole number of tiles, with the whole number of tiles. Okay, so what will be the maximum size of the square, so that a whole number of tiles will be required to cover the floor. Now, if this area of the floor, which is 49 by 4 multiplied by 7, if this would have been a perfect square, if this would have been a perfect square, then the square root of the area would be the size of the square, and we would have required only one square tile. But 49 by 4 multiplied by 7 is not a is not a perfect square. Mm, is not a perfect square. 49 by 4. Okay. What is the maximum length of us? Now, please note that 49 by 4 can be written as 7 square. So 49 is 7 square, and 4 is 2 square, multiplied by 7 meter square. Let me, for the time being, remove this line. So the area is can be represented as 7 square by 2 square multiplied by 7, this much meter square. Now 7 square by 2 square can be written as 7 by 2 whole square multiplied by 7, this much meter square. So the area, um, what is the maximum length of a square tile? Okay. Um, so uh, so we can see that if the length of the square tile is 7 by 2 meter, then then its area will be 7 by 2 whole square. So we can seven such tiles, seven square tiles, where the length of each square tile is 7 by 2 meter, uh, could be one possible solution. Mm, Now, 100. If but is there any possibility that we can consider a greater length, uh, a larger length of the square tile, a larger length of the square tile, mm, so that a whole number of such square tiles will fill the entire area of the floor? The maximum length of a square tile to fill the floor of the room with a whole number of tiles, with a whole number of tiles. Mm, Whole number of tiles, 7 cube, maximum. Mm, maximum. So basically, whatever this area is, somehow we have to express this area as in the form. So whatever this area of this floor is, let's say this area is A. So the area of the floor has to be in the form of n, where n is a whole number multiplied by some xs square, where where x is the length of square tile. So if uh, so if x is the length of the square tile and n is the number of such square tiles, then n number of square tiles where the length of the each square tile is x, its area, the area will be n multiplied by x square. So if we can somehow express the area of the floor, which is 49 by 4 multiplied by 7, in the form of n multiplied by x square, and then we can find n and x, so that n x is maximum, so that x has to be maximum. X has to be maximum. Okay, now x square multiplied by n. So the area has to be expressed in the form of x square multiplied by n. So there has to be a whole number and then multiplied by a square of some number, that is x, which will be the length of the square tile. So the area is 49 by 4 multiplied by 7, and we have to maximize x, so that x square multiplied by n, and n can be any natural number greater than or equals to 1. So the area is 49. The area is 49 by 4 multiplied by 7, which is equal to 7 multiplied by 7 multiplied by 7, and then we have 2 multiplied by 2. So this whole thing has to be expressed in the form n multiplied by x square, so that x is, we have to maximize x. Now clearly you can see the only way of expressing the area of the floor in the form of n into x square is 7 by 2 whole square multiplied by 7. So x has to be equal to 7 by 2 meter. 7 by 2 meter, but x has to be 7 by 2 meter, and also we can say that n, that is the whole number of tiles, will be 7. Whole number of tiles will be 7. 49. Okay, so what is 7 by, so then the length of the maximum length of the square will be 7 by 2 meter, and the choices are given in centimeter. So how much is 7 by 2 meter in centimeter? This is 7 by 2 multiplied by 100 centimeter, and this is coming out to be 350 centimeter. But we do not have 350 centimeter as a choice. Let me quickly check if I have copied all the choices correctly or not. This is area and perimeter. Room. Yes, the choices are correct. 125 centimeter, 150 centimeter, 175 centimeter, and 200 centimeter. The choices are correct. So the maximum length of a square tile. The length of a square tile means the side of the square tile to fill the floor of the room. The maximum length of a square tile to fill the floor of the room with a whole number of tiles. Whole number of tiles mm, is maximum length 48, 49 by 4, 49, 12 and 1 by 4th meter is 49 by 4 meter. So 49 by 4 multiplied by m is the area of the floor, and we have to somehow express 49 by 4 multiplied by 7 in the form of n into x square, where n is a whole number and x will be the n is a whole number, that is the number of tiles required, square tiles required, and x is the maximum length of the square tile. Okay, so 49 by 4, 49, so 49 by 4 is 7 into 7 and 7, okay, 7 into 7 into 7 divided by 2 into 2, uh, 4, 8, 9 by 4. With a whole maximum, with the maximum 7 by 2. Uh, mm, I don't know, 49 by 4, I think 49 by 4 is correct. 49 by 4 should be the length of the 49 by 4, I mean, 49 by 4 should be the area of each square tile. That is 7 by 2 should be the 7 by 2 meters should be the length of each square tile, which is equal to 350 centimeter. The maximum length of a square tile. The maximum length of a square tile to fill the floor of the room with a whole number of tiles is the maximum length of a square tile. What is length referring to? Is it the side of a square or a square tile to fill the room with a whole number of tiles? I don't know. I think my answer is coming out to be 350 centimeter. Maybe I'm not able to understand the problem properly. If you are able to solve this problem, please do let me know in the comment section. I will highly appreciate that. As for my understanding, I think 350 centimeter should be the maximum length of a square tile, and the whole number of tiles required will be 7. Mm, will be 7. Okay. Let's do the next problem. Sorry, I failed to solve the problem number 1 properly. Question number 2. Question number 2 says that a man walking at the speed of 4 kilometers per hour crosses a square field diagonally in 3 minutes. The area of the field is. Okay, so a square field. So there is a square field. Let's say ABCD be the square field, A, B, CD be the square field. So let's say BD is the diagonal, and a man walking at the speed of walking is given to be equal to 4 kilometer per hour, and a time taken uh, to cover a BD, that is the diagonal of the square field, is given to be 3 minutes. 3 minutes, which is equal to 3 by 60 hour. So this implies what is the distance of so distance distance covered in 3 minutes. Distance covered in 3 minutes based on the speed of walking is 4 km per hour. So distance covered in 3 minutes will be 3 minutes is equal to 3 by 60 hour. So it will be 4 multiplied by 3 by 60, this much kilometer, which is equal to 1 by 5 kilometer. So this implies which is equal to 1000 by 5 meter, which is equal to 200 meter. So this implies the distance covered in 3 minutes, the distance covered is BD, that is the diagonal. So this implies BD is equal to 200 meter, and it is a square. So it is asking the area of the field is. We know that for a square, if ABCD is a square, we know that area of a square is equal to diagonal square by 2. This is a formula you must remember or know, that for a square, area is equal to diagonal, the length of the diagonal square, divided by 2. So in this case, the diagonal is 200. So this will be 200 square by 2, this much meter. This much meter square. This is equal to 40000 by 2 meter square, and this is equal to 20000 meter square. So 20,000 meter square is the area of the square field. So the correct choice is C. C is the correct choice. Okay, let's do problem number 3. So problem number 3. Okay, so we have a figure. A rectangle is divided into a square A and 3 smaller rectangles B, C and D. Okay, the areas of ABC are 9 centimeter square, 15 centimeter square and 40 centimeter square respectively. Then area of D is. Okay, so we are having the figure like this. So a rectangle is divided into a square A. So A is a square. Okay, A is a square, and a 3 smaller rectangles. So D is a rectangle, B is a rectangle, and C is a rectangle. Such that the areas of A and B, area of A is given to be 9 centimeter square. Since A is a square, this will imply that let's say this okay, so since A is a square, let's say the side of the square is x, let's say x centimeter. So this will be this will also be x, and this will also be x. So this implies we must have x square. So the side length of the square A will be we are assuming that the length of the side of square A is x centimeter. So its area will be x square. So we must have x square equals to 9. So this implies x will be equal to square root of 9 centimeter, which is equal to 3 centimeter. So the each side length of the square A is 3 centimeter. Also, it is given that area of B and C are given. We have to find the area of D. where we know that the breadth of the rectangle D is x. Okay, so area, let's say this length, this length be y. Let's say this length be y, and let's say this length be z. Okay, so this length be z. Okay, so area, what will be area of B? Area of B now will be xy centimeters square, which is equal to x we know is 3. So this will be 3y centimeter square. So this implies area of B is given to be 15 centimeters. So we must have 3y is equal to 15. So this implies y is equal to 15 by 3, which is 5. So y is 5 centimeter. Okay, y is 5 centimeter. Okay, now what is area of C? Area of C is also given. Area of C will be equal to yz centimeter square, which is equal to y we know is 5. So this will be 5z centimeter square. This implies area of C is given to be 40 centimeter squared. So we must have 5z is equal to 40. So this implies z is equal to 40 by 5, which is equal to 8 centimeter. So we know z and we know x. So we can now find the area of D. Area of D will be equal to, the length is z and the breadth is x, this much centimeter square, which is equal to 8. Z is 8 centimeter and x is 3 centimeter. So this much centimeter square, which is equal to 24 centimeter square. So the correct choice is B. B is the correct choice. Okay, let's do problem number 4. The length of a rectangle is halved and its breadth is tripled. Okay, so let's say this is a rectangle. We have length and we have breadth. The length of a rectangle is halved and its breadth is tripled. What is the percentage change in area? So let's say after the change of the length and breadth, it is given that the length of the breadth is halved. Okay, so length is halved and breadth is tripled. Okay, so let's say this becomes the rectangle. Let's say this be L dash and not L dash. So this is L by 2. So the length is halved and the breadth is tripled. So this is 3b. We have to find the area of these two rectangles and find what is the change in area. What is the percentage change in area? Remember that the percentage change in area will be based on the original rectangle, that is whose length was L and B. So for this area, for this rectangle, area is equal to LB, and for this rectangle, area will be equal to L by 2 multiplied by 3B, which is equal to 3 by 2 LB. So what is the change in area? Change in area. Now the change can be less or change can be more. So the choices are, as you can see, the choices are given as 25% more or 50% more or 50% less or 75% less. Now clearly, after the length is halved and the breadth is tripled, the area is 3 by 2 LB, and 3 by 2 LB we know that 3 by 2 LB is greater than LB, because 3 by 2 is greater than 1. So this implies increase in area, increase in area is equal to 3 by 2 LB minus LB, which is equal to LB by 2. So this is the increase in area. So therefore, this implies percentage increase in area will be equal to LB by 2. So this is the increase in area based on the original area, which is LB, and then multiplied by 100. This much percentage is the increase in area. This is equal to 100. This is equal to 100 by 2 percentage, which is equal to 50 percentage. So the percentage change in area will be 50% more, since there is an increase in area. So the correct choice is B. B is the correct choice. Okay, let's do problem number 5. 36 unit squares. 36 unit squares. Unit squares means a square having area 1 square unit. 36 unit squares are joined to form a rectangle with the least perimeter. The perimeter of the rectangle is with the least perimeter. Okay, so with the least perimeter. So 36 unit squares are joined to form a rectangle with the least perimeter. Now, when 36 unit squares are joined to form a rectangle, the one thing that will remain the same is the area. The area of the 36 unit squares is 36 square units. So the area of the rectangle will also be 36 square units, and we have to then we have to find the dimensions so that its perimeter is least. Perimeter is least. Okay, so when 36 unit squares 36 unit squares, so we must have area of rectangle should be equal to area of 36 unit squares. This is equal to 36 square units. Okay, so now we have to, so the area of the rectangle should be 36 square units. Now we have to give what will be the dimension of the rectangle, that is what will be the length and breadth of the rectangle, so that the area, that is L into B, will be 36, but the perimeter, that is 2 into L plus B, will be least. So okay, so let L equals to length of rectangle, B equals to breadth of rectangle. So this implies LB is equal to 36. Perimeter P perimeter will be equal to 2 multiplied by L plus B. Now, so the idea is that what values we can give to L and B such that L into B is 36, and the perimeter is, that is 2 into L plus B, is least. Now P, remember that the concept is P is least when L plus B is least. Perimeter, the formula for perimeter is, the formula of perimeter of a rectangle is 2 into L plus B. So when will 2 into L plus B will be minimum? When the value of L plus B will be minimum. Okay, now please see that all the choices are given as, all the choices, the perimeter, all the values of the perimeter are natural numbers, are whole numbers. So definitely we have to choose L and the values of L and B as natural numbers, so that L into B is 36, but L plus B is minimum. L plus B is minimum. Now, among all the choices, among all the given four choices, the minimum is 12. So, the minimum is 12. So, let's see if A can be a possible perimeter of the rectangle. So, okay, so one more thing, we can also solve in this way. So, LB is equal to 36. Now 36 can be expressed as 9 multiplied by 4 or 12 multiplied by 3. It can be 6 multiplied by 6. So these are the possible ways of the 36 can be expressed as the product of two numbers, two natural numbers. So it can be 9 into 4 or 12 into 3, or it can be 6 into 6, or it can be 18 multiplied by 2. 18 multiplied by 2. So these are the possible ways of expressing 36 as the product of two natural numbers. Now we have to see, in all these cases, in all these possible, in all these possibilities, 9 into 4 means that the length or breadth will be 9 and 4. The length, if we consider 36 as 9 into 4, this means that the length will be 9 and breadth will be 4. So in this case, the sum is for this one. If we consider 36 as if we express 36 as 9 into 4, then L plus B is coming out to be 13. If we consider 36 as 12 into 3, then the length will be 12 and the breadth will be 3, and L plus B will be 15. And if we consider 6 into 6, then it will be a square, that is length and breadth both will be equal to 6, and L plus B will be equal to 12. And if we consider 18 into 2, the length will be 18 and breadth will be 2, and L plus B will be equal to 20. So certainly 12 is the minimum value of L plus B, and hence the perimeter, hence the least perimeter, P is least, P, that is the perimeter, is least when L is equal to B is equal to 6 centimeter. So this implies minimum P, that is the minimum perimeter, is equal to 2 into 6 plus 6 centimeter, which is equal to 24. Not centimeter, it is given in units, so it will be units. Length and breadth will be 6 units. So the perimeter, least perimeter, will be 2 into length plus breadth, which is 24 units. So the correct choice is B. B is the correct choice. Okay, let's do the last problem. Question number 6, we have a figure. The figure shows three identical rectangles X, Y and Z. So X, Y and Z are identical rectangles, meaning they are congruent rectangles, and two shaded areas of the same size. So the shaded areas are of same size. Okay, let's quickly draw the diagram. So we have three congruent or identical rectangles. Okay, so we have something like this. Okay, so These are okay. So and two shaded areas of the same size. So the area of the two shaded regions are same. Let's mark. Let's give names to the mm, corner to the vertices or to the intersecting points so that we can refer the regions. Okay, so this is X, rectangle X, and this is Y, and this is Z. Okay, so given that two-fifth of rectangle X is shaded, two-fifth of two-fifth of rectangle X is shaded, what is the ratio of shaded areas to the area of the whole figure? To the area of the whole figure. Okay. Now, what is the area? First of all, what is the area of the whole figure? Uh, the area of the whole figure uh, mm, area of the whole figure. Okay. Now, if you add up the areas of x, y, and z, the area x, y, and z, they are identical rectangles, so their areas will be same. So if you add now the whole figure, if you add the area of x, y, and z, then uh, then uh, this part will be considered twice, and also this part will be considered twice in the area. If I add up, so why is this so? Because this area, these two shaded area, let's say this be uh, let's say this be A, B, C, let's say this be D, E, F, G, and H. Now the shaded areas are the shaded area ABCD. The shaded area ABCD is common to the ABCD. So ABCD is common to X and Y, the rectangles X and Y. Also, EDGF is common to Y and Z. Is common to Y and Z. So, if so, we must have area of whole figure. Area of whole figure will be area of X plus area, that is the rectangle X. Even though the rectangle XYZ, they are all identical rectangles. So area of X plus area of Y plus area of Z. But then we have to subtract the area of the regions ABCD once and also subtract the area of EDGF once, because if you in this sum, that is area of X, Y, and Z, the rectangle or the region, the shaded region ABCD has been considered twice. Also, the shaded region EDGF has also been considered twice. So we must subtract the area of ABCD and subtract the area of EDGF. Okay. Now, what is area of A and since XYZ are all identical rectangles, they are identical rectangles means they are congruent rectangles, and congruent figures always have equal areas. So area of X will be A plus area of Y will also be A plus area of Z will also be A minus what will be area of ABCD, that is the shaded region ABCD. It is given that the two shaded areas of the same size, the two shaded areas are of same size, and that 2/5 of the rectangle X is shaded. 2/5 of the rectangle X is shaded means area of ABCD. So ABCD is the shaded area region of the rectangle X. So area of the shaded region ABCD will be 2 by 5 of X of A, 2/5 of A, where A is the area of the rectangle X or Y or Z, and also the area of the other shaded region will also be same. So we have 2 by 5 of A. So this is equal to 3A minus 2/5 of A means 2 by 5A minus 2 by 5A. So this is equal to 3A minus 2 by 5A plus 2 by 5A, 2A by 5 plus 2A by 5. This will be equal to 3A minus 4A by 5, which is equal to 15, and 11A by 5. 11A by 5 is the total area of the total figure. Okay, and so 11A by 5 is the area of the total figure. So what is the problem asking? What is the ratio of shaded areas to the area of whole figure? So 11A by 5 is the area of whole figure. Okay, now what is area? Area of shaded region, let's say, is nothing but area of ABCD plus area of EDGF. This was, we just did it, 2A by 5 plus 2/5 of the area of the shaded regions is basically given in the problem as 2/5 of the rectangle X, and we have assumed that A is the area of all the three identical rectangles. That is, A is the area of individual area of all the three identical rectangles. So we have this. This is 4A by 5. So 4A by 5 is the area of the shaded regions. So this implies required ratio, that is required ratio is area of whole figure divided by area of shaded region, which is equal to area of whole figure is 11A by 5, and area of the shaded region is 4A by 5. This is equal to 11A by 5 multiplied by 5 by 4A. 5 cancels out, A cancels out. This is equal to 11 by 4, which is equal to 11 is to 4. So 11 is to 4. Why it is coming 11? The choice is given as 4 is to 11. Oh, what is the ratio of shaded areas to the area of the whole figure? I have found the area of whole figure divided by area of shaded region. Okay, So if the area of whole figure divided by area of shaded region is equal to 11 by 4, so definitely the ratio of a shaded region and the whole figure will be 4:11. So the correct choice is A. A is the correct choice. So with this, it comes to an end in solving 5 good problems, not 5 good problems, but some conceptually good problems on area perimeter of rectangle and square. I hope solving this problem will give you a good practice of applying your concepts of area and perimeter or of square and rectangles. So if this video was beneficial, please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Some problems of exercise 20b are left, which are the problems based on finding the area of shaded region. So which are the problems? Problem number 14, 15 and 16 of exercise 20b on the chapter of mensuration. So in the next video, I will solve those 3 problems of exercise 20b on the chapter of mensuration from the textbook of author RS Aggarwal. So please stay tuned for that video. It is coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.